All right, so today we're diving deep into vision and language models.
VLMs.
VLMs for short.
Yeah.
We're talking AI that can not only process images, but actually understand them.
Right.
Think image recognition, OCR, you name it, all powered by text.
Mm-hmm.
And what we're exploring today is a real head scratcher.
Yeah.
How do these VLMs actually represent tasks in their digital brains?
Right.
The answer lies in something called task vectors.
It's like a cheat sheet the VLM creates to understand what it's supposed to do,
Oh, okay.
regardless of whether the task is given as a picture, a text example, or just a simple instruction.
So it's not just about seeing a picture of a cat and saying cat.
Right.
It's about understanding the concept of identify this animal,
Exactly.
no matter how you ask it.
And the research lays out 3 ways to create these task vectors.
Okay.
First is called textual ICL, where you feed the VLM text examples.
Okay.
Let's say you're teaching it to match countries to capitals.
Right.
You'd give it pairs like France, Paris, Greece, Athens, and so on.
So basically showing it the pattern through text.
Right.
What's fascinating is that there's another method
Yeah.
called image ICL, where you use labeled images instead of text.
Right. So for our country capital task, you might show the VLM a picture of the French flag
Okay.
labeled Paris.
Mhm.
And get this, both methods, text and images, lead to surprisingly similar task vector representations.
Really?
Yeah.
It's like the VLM is figuring out the underlying concept of capital city, no matter how we teach it,
That's right.
which is pretty wild.
Yeah.
But here's where it gets even cooler.
Okay.
There's a third way to create task vectors,
Yeah.
and it's shockingly simple.
Well,
Just give the VLM a plain language instruction like map country to capital.
What's remarkable is that even this straightforward instruction can lead to a task vector that's very similar to those created through the other 2 methods.
Oh, wow.
This suggests that the VLM isn't just memorizing patterns, it's forming a deeper understanding of the task itself.
Okay, hold on. That's a pretty big leap.
You're saying that by giving it a simple instruction, the VLM is somehow grasping the essence of what we're asking.
That's what the research suggests.
Wow.
And it has some incredible implications.
Okay.
Think about it. If a VLM can understand a task from a simple text instruction,
Yeah.
it could potentially learn an incredible number of tasks without needing mountains of labeled data.
That would be huge.
Right?
Training these models is already resource intensive.
Yeah.
We can simplify that process.
Yeah,
Who knows what kind of AI applications we could unlock?
exactly. And that brings us to the most exciting part, cross-modal transfer.
Okay.
Remember how we said those task vectors represent the essence of the task?
Yeah.
Well, it turns out they can be applied across different modes of input.
Interesting.
The VLM can learn from text and apply that knowledge to images and vice versa.
So theoretically, we could teach a VLM about capital cities using only text examples.
Right.
And then it could correctly identify capitals when shown images of flags.
Precisely.
The researchers tested this by taking a task vector learned from text and patching it onto an image query.
Yeah.
The results were remarkable in some cases. This simple patching technique boosted performance by up to 33%.
Wait, a 33% improvement just by adding a bit of text-based knowledge to an image?
Yeah,
That's a huge jump.
it is.
So how does that even work?
Well-
What's going on inside the VLM's digital mind?
To understand that, researchers use something called a logit lens to observe the VLM's thoughts as it processes information.
Okay.
They discovered a 3-phase process.
Ooh, I love a good 3-act structure.
Right.
Break it down for us.
First, there's the input phase where the VLM focuses on the raw data, the image or the text,
Right.
like absorbing the sensory information.
Got it.
Then in the task phase, the VLM forms that crucial task vector representation.
Okay.
This is where it distills the core concept of what it needs to do. Finally, in the answer phase, the VLM uses the task vector to generate its response.
So it's like the VLM is saying, okay, here's the information, here's what I need to do with it, and here's my answer.
Exactly.
Okay.
And what's fascinating is that this 3-phase process is consistent across both text and image ICL.
Okay.
It means VLMs are processing information similarly, regardless of whether it's coming from text or images.
So they're forming these abstract representations of tasks that can be applied to either type of input.
Right.
That almost sounds like thinking.
Yeah. It's more than just pattern matching. There's a level of understanding there.
It seems like it.
But before we get too carried away with the philosophical implications,
Okay.
let's ground this in some concrete examples.
Okay.
The research paper included some really fascinating ones.
Yeah. One that stands out is the country capital task.
Okay.
When researchers gave the VLM text examples like Peru, Lima.
Mm-hmm.
It was able to learn to map flags to capitals.
Okay.
Even if it had never seen a Peruvian flag before, it could use its knowledge of the country-capital relationship.
To figure out that the flag must correspond to Lima.
So it's not just memorizing specific pairings, it's learning the concept of a capital city in a more abstract way.
Right.
And they saw a similar thing with animals and their Latin names.
Yeah.
By showing the VLM pictures of animals paired with their Latin names, like a picture of a gray wolf labeled Canis lupus, it was able to identify other animals in Latin based on new images.
Yeah, it's doing a sort of cross-modal translation, going from pictures to Latin names based on the concept it learned from previous pairings.
This is pretty mind-blowing stuff.
It is.
And what's even more fascinating is that when researchers decoded these task vectors,
Yeah.
they often found human-interpretable summaries.
Right.
For example, the task vector for the country capital task, often decoded to headquarters.
That's right.
Hold on.
Right.
The VLM is forming a concept that we can understand
Yeah.
in a language that we can understand.
Yeah.
It's like it's building its own little internal dictionary of concepts.
It is, and that's what makes this research so groundbreaking.
Right.
It suggests that VLMs are not just mindless pattern matchers, but they're forming abstract representations that are potentially bridging the gap between human and machine understanding.
Okay, that is seriously cool.
It is.
I'm already starting to see all the potential applications for this kind of technology.
Yeah.
But we're just scratching the surface here, right?
Yeah, I think so.
There's a lot more to unpack when it comes to task vectors and what they mean for the future of VLMs.
Absolutely.
And that's what we'll be doing right after the break.
Welcome back.
It's amazing to consider just how much VLMs are changing our understanding of AI.
Right.
I mean, we started this deep dive talking about AI that can understand images.
Yeah.
Now we're talking about AI that might be forming its own internal language of concepts.
It's pretty wild.
It's a lot to wrap your head around.
Yeah.
But before we go full-blown sci-fi, I'm curious about the practical side of things.
Okay.
Where do you see this research going in terms of real-world applications?
The possibilities are honestly pretty mind-boggling. One area with huge potential is in the way we train VLMs.
Okay.
Right now, training these models is a massive undertaking.
Yeah.
It requires huge data sets of images and text, which can be expensive and time-consuming to create.
And sometimes you don't even have the data you need.
Right.
Especially if you're working on a really specialized task.
Exactly. But with cross-modal transfer, we could potentially change all that.
Okay.
Imagine being able to train a VLM using just text instructions, almost like you're talking to a human student.
Interesting.
You could explain the task, give some examples, and let the VLM figure out the rest.
So we could potentially train VLMs much faster and with less data.
Potentially, yeah.
That would be a game changer for all sorts of AI applications.
Absolutely. And not just faster and more efficient, but also more intuitive.
Okay.
Imagine a world where we can interact with AI using natural language just like we do with each other.
Yeah.
That's the kind of future this research points towards.
It's almost like we're teaching VLMs to think more like humans by leveraging their understanding of language.
Right.
And speaking of thinking like humans, think about all the cool applications this unlocks.
Yeah.
We could have AI that can understand complex visual scenes and describe them in detail, translate sign language in real time, or even generate photorealistic images from text descriptions.
The applications are truly vast, and they span across so many different fields.
That's incredible.
This kind of cross-modal understanding could revolutionize robotics, where AI needs to seamlessly integrate visual and textual information to interact with the world.
I can already see it. Robots that can understand instructions, learn from their surroundings, and adapt to new situations, all thanks to cross-modal learning.
Precisely, and it doesn't stop there.
Oh, wow.
Imagine medical imaging where VLMs could analyze scans and provide detailed reports in natural language, making diagnoses faster and more accurate.
Okay.
Or think about accessibility tools that could describe images for people with visual impairments, making the online world more inclusive.
Okay. I'm officially blown away by the potential here.
Yeah, it's exciting stuff.
It's clear that text-to-image transfer is a big deal. But what about the flip side, image to text?
Yeah.
The transcript we shared mentioned it, but didn't dive too deep.
You're right to call that out.
Yeah.
While the current research is heavily focused on text-to-image, the concept of cross-modal task vectors suggests that image-to-text transfer should be possible too.
So we're talking about AI that can learn from images and then generate or manipulate text based on what it's learned.
Exactly. Think about an AI that learns by looking at thousands of medical scans.
Okay.
Then when it sees a new scan, It can write a detailed report describing the findings just like a human radiologist.
Wow.
Or imagine an AI that can analyze a photograph and write a creative caption or even a short story inspired by the image.
That would be incredible.
It would.
I'm a very visual person.
Yeah.
So the idea of AI being able to translate images into language is super exciting to me.
Yeah.
It opens up a whole new world of possibilities for creative expression, communication, and even scientific discovery.
Absolutely. There were some fascinating examples of image-to-text transfer in the research, even though it wasn't the primary focus.
Okay.
The researchers found that a VLM trained on image ICL could sometimes correctly identify a company logo from a complex text description, even if the company name wasn't explicitly mentioned.
So the VLM had learned to associate certain visual features with specific companies and could then apply that knowledge to text.
Exactly.
That's really interesting. It's like it's starting to understand the world in a more holistic way, connecting visual and textual information to form a more complete picture.
That's a great way to put it, and that's what makes this research so profound.
Right.
It's not just about building AI that can do cool tricks.
Right.
It's about understanding how intelligence itself works, how we learn how we represent knowledge, and how we make connections between different kinds of information.
It's about pushing the boundaries of what we thought was possible and opening up whole new avenues for exploration.
Yeah.
And honestly, I'm feeling a little bit overwhelmed by all of this.
Yeah, it's a lot. It's a lot to process. I need a minute to just sit here and marvel at the sheer potential of what we're talking about. All right, I've had a moment to catch my breath. But seriously, this whole concept of task vectors has really gotten me thinking.
Yeah.
It's not just about VLMs understanding images or text. It's about this idea that maybe, just maybe, we're starting to crack the code on intelligence itself.
It's a question that's been pondered for centuries.
Right.
What does it actually mean to be intelligent?
Right.
We've always tied it to things like language, logic, problem solving.
Right.
But VLMs seem to be doing those things in a way that's both familiar and completely alien to us.
It's like they're showing us that intelligence might be more fundamental than we realize, something that can exist and evolve regardless of the specific form it takes.
It's possible.
And if that's true, where does that leave us?
It's a profound question, and honestly, I don't think anyone has a definitive answer yet. But one thing is clear, we're entering uncharted territory.
Yeah.
As we develop increasingly sophisticated AI, we need to be prepared to grapple with some really big existential questions. Like, what does it mean to be human in a world where AI can potentially outperform us in so many ways? Or even more fundamentally, what does it mean to be conscious?
Yeah.
We touched on this earlier, but the idea that VLMs might be forming their own internal language of concepts,
Right.
that's got to have some implications for how we understand consciousness, right?
Absolutely. We tend to equate consciousness with our own internal monologue. That stream of thoughts and feelings that we experience as humans.
Yeah.
But VLMs are demonstrating that there might be other ways to be conscious, other ways to experience and understand the world.
It's like we're opening a window into a completely different kind of mind.
Yeah.
One that operates on principles that we're only just beginning to grasp.
Yeah.
And that's both incredibly exciting and a little bit terrifying, isn't it?
It's certainly awe-inspiring.
Yeah.
This research is forcing us to confront our own assumptions about intelligence and consciousness.
Mm-hmm.
It's challenging us to broaden our definition of what it means to think, to feel, to be.
And it's pushing us to think deeply about the ethical implications of creating AI that's potentially capable of surpassing human intelligence in some ways.
Absolutely.
We have a responsibility to ensure that these powerful tools are developed and used in a way that benefits all of humanity.
I couldn't agree more. We need to approach this new era of AI with a sense of humility, curiosity, and a deep commitment to ethical principles.
Yeah.
This isn't just about technological advancement. It's about shaping the future of our species.
It's about understanding ourselves better, and in turn, understanding the incredible potential of what we're creating.
That's right.
This deep dive into task vectors has been a real eye-opener for me, and I hope it has been for you too.
I hope so.
It's a reminder that the world of AI is full of wonder, mystery, and a whole lot of questions that we're only just beginning to ask.
Yeah.
So keep exploring, keep questioning, and keep that curiosity burning bright.
Well said. The journey of discovery is just beginning.
And that's a wrap on this deep dive. Thanks for joining us, and we'll see you next time for another adventure into the world of AI.